Assalamu alaikum. In this series, Mr. Omar has guided you through some practice problems to cover all items included in the coverage issued by Emirates Schools Establishment, E.S.E. This is the last part. Have a fruitful time.
Assalamu alaikum wa rahmatullahi wa barakatuh. I hope that is the last part, and if it is very long, so forgive me. Question 6. Find the current in each branch in the following circuit. Then find the maximum charge on either plates of the capacitor. First, let us analyze the circuit. It is a DC circuit, so any branch with a capacitor has no current. So from A to H, the current is 0. B, A, H, G, there is no current. The current here is 0. And here, since it's the same branch, the current here is 0. So we have only two currents in the circuit, two loops. The third loop will ignore. Here one loop with two junctions. Here is the other loop with 4 junctions. And if you need, this is the fourth one or the third loop. This is the second and this is the third. Now, suppose there is a current going from this battery, is I1. It will not splitting to A, so it will continue here, I1. But at C, it will be splitted into two currents. Suppose this is I2 and this is I3. I3 can continue to D, then to E, and it will fall from E to F. I2 will continue to F. It will meet I3 and they will together form I1 again. It will go to G, then it will go to B. So there is no current from G to H to A to B. Now, if you apply Kirchhoff junction rule at point C, sigma I equals 0, I1 will go into C, so it is positive. I2 and I3, they are negative. So I1 minus I2 minus I3. Why we put a negative sign for I2? Because we consider the in current positive and the out current from the junction is negative. So this is the first equation. Now, Kirchhoff loop rule on the first one, the upper loop, from C to D to E to F to C again, sigma BMF minus sigma IR equals 0. Now if you go from C to D to F to C again, we have only one battery, which is 14 volt, and I'm going clockwise, but this battery is going from C to F, so it is against me. It should have a negative sign, so it is minus 14 minus bracket. Now from C to D the current is I3, and I'm going from C to D, in the same direction, and I3 is going through 4 ohm and 3 ohm at the same time. So it is with me, so it is positive R plus 3 times I3. Now from F to C, from F to C, the current is I2 against me, so it is negative. So I have, here we have bracket, negative I2 with no resistance, so don't mention it. Don't need it. Since there's no resistance to the branch F. All of this is equal to 0. So minus 14 minus 7I3 equals 0. I3 will be equals minus 14 over 7, which is minus 2 ampere. It is against the direction that we suggested before. Now let us find I1 and I2. Apply Kirchhoff loop rule on the second loop. From B to C to F to G to B. Sigma VMF, electromotive force, minus sigma I times R equals 0. From B to C, we have no battery. From C to F, we have a battery, and in the same direction of the analyzing, so it is positive 14. Here, from F to G, there is no battery. From G to B, we have a battery in the same direction of analyzing, so it is positive. So both batteries are positive, 14 plus 8, minus bracket. Now, let us find the potential drop through the currents. From B to F, there is no resistance. From C to F, also there is no resistance. From F to G, we have a resistance 4 with a current I1 in the same direction of analyzing, so it is positive. From G to B, there is no resistance. So we have only I1 times 4. The resistance is 4 and the current is I1. This negative from the equation, not from the analyzing, equals to 0. So 14 plus 8, it's 22. So I1 is 22 over 4, which is 5.5 amperes. Now go back to equation 1. Equation 1 says that I1 minus I2 minus I3 equals 0. I1 it is 5.5, minus I2 it is unknown, minus I3 it is minus 2 in our analyzing, equals 0. Minus 1 minus 2 minus plus 2 plus 5.5, so 7.5. Then I2 equals 7.5 ampere in the same direction and indicated on the graph. Okay, these are our 3 currents. Now, to find the maximum charge on either plates of the capacitor, Apply Kirchhoff loop rule on the third loop. Sigma VMF minus sigma IR equals 0. Now if you go around the third loop from A to B to G, we have an opposite battery to us. It is minus 8. Continue from H, then here we have again opposite battery for us. It is minus 3. And for the potential difference on the capacitor, it is in the same direction of the analyzing, so it is positive. The capacitor minus no resistance from A to B to G to H to E to A, so I times 0 equals 0. So VC equals 11 volts. Here we have the voltage for the capacitor. We can find the charge on the capacitor. Q on the capacitor, it's Q maximum because there is no current flowing in this branch. It is C times V. The capacitance of the capacitor as indicated in the graph, it is 6 microfarad. So it is 6 micro 10 to the minus 6 times 11. So it is 66 times 10 to the minus 6 coulomb, or 66 micro coulomb. The seventh question. The ammeter shown in the following diagram reads 2 ampere. Find I1, I2 and epsilon. So put the data on the graph. The ammeter has a current of 2 amperes. We need to find I1, I2 and epsilon. Also, it is not a classical question. It needs some clever, not much, but a simple thinking will yield the question answer. First, put some symbols on the graph, or the diagram, sorry. A, B, C, D, E, F. We have a current from E to B. So let us take this loop and apply Kirchhoff loop rule in that one to find I1. Let us name this current as I3. Now, Kirchhoff loop rule on the first one, sigma VEMF minus sigma IR equals 0. Through this loop, we have only one battery. I am going clockwise, and the battery comes from right to left, so it is opposite to the analyzing direction. So it is minus 15 minus, now the currents from B to C, the current is I1 passing through 7 ohm. So, and it is opposite to me, so it is 7 I1 in the opposite direction, so it is negative. Put the bracket here. Plus, if you go from E to B, the current is with you, and it is flow through 5 ohms. So 5I3 equals 0. Minus 15, minus time minus plus 7I1 minus 5I3 equals 0 minus 15 plus 7I1 minus 5 times I3, it is 2. So minus 5 times 2 minus 10 with minus 15 minus 25. So I1 equals 25 over 7 amperes. Now we can find I2 applying Kirchhoff junction rule at point B. Sigma I equals 0. I1 going to the left, I3 left, I1 down, I2 up. So all of the currents are going into B. So all of them are positive. I1 plus I2 plus I3 equals 0. I1, it is 25 over 7. I2, it is unknown. I3, it is 2. Then I2 equals minus 25 over 7 minus 2, 14 minus 39 over 7 amperes in the opposite direction shown. Now to find E, apply the Kirchhoff loop rule on the second. We have only one battery. If you go clockwise, only one battery. With me, it's epsilon. So Kirchhoff loop rule on the second loop, sigma VMF minus sigma IR equals 0. It is epsilon minus bracket. Now for the currents, in the lower branch, the current is I2 and it is in the same direction of the analyzing, so it is positive, I2. It is flowing through 2 ohms, and I3, it is against the analyzing because I am going clockwise, so it is negative and flowing through 5 ohms. So I have I2 times 2 minus I3 times 5. 2I2 minus 5I3 equals 0. Epsilon minus 2. I2 it is minus 39 over 7 minus 5 times I3 it is 2. Epsilon minus, this is 78 over 7 minus 10. So it is 8 over 7 volt. Epsilon 8 over 7 volt. That's it. In the same direction indicated in the question. Now, is there another answer for this question? Yes, for sure. Because we assume that the current through the ammeter is flowing to the left. What about if it is flowing to the right? So resolve this question if 2 amperes is to the right from B to E. The question should indicate that. The question must say that the ammeter shown in the following diagram reads 2 ampere and the current is flowing from left to right or right to left, or he put a polarity on the ammeter, negative, positive. Okay. So if the current here is the ammeter positive and negative, so it is flowing to the left, or opposite to that, it is flowing to the right. So it should be indicated in the question. But in such a question, you need to solve the question 2 times. First time the current from left to right, the other one from right to left. Don't forget this information, please. It is a shortage in the question, but if we faced with this in the exam, we should have 2 answers. Now, I think these questions are very interesting questions, more than the one in the book. Some maybe find this question is hard, but it is very easy. So I'll give you the idea and leave the answer for you. This is not 2 loops. You can make it 1 loop. How? Before solving by Kirchhoff, try to simplify the circuit. Here we have the 3 and 1 ohm in series, so they are equivalent to 4 ohms. Then 12 and 4 are in parallel, 12 parallel to the 4. So they will be equal to 3. 12 times 4 over 12 plus 4. So you can remove everything between C and G and put between C and G only a resistance with 3 ohms. Then follow your circuit. It's a very easy question. This is 3, this is 2, 12, 4. Now you can take this only one current, which is I3, and take this direction for analyzing. This voltage is with you, 12, and this voltage is against you, 4. So 12 minus 4 minus the current is I3, and it is flow through 2, 3, 3. 2 plus 3 plus 3 equals 0. 12 minus 4, it is 8, minus 8I3 equals 0. Then I3 equals 1 amperes. And that's it. Now, find the current in each branch. We find the main current. Now, we want to split it into 2 branches for I1 and I2. I1 and I2 are in parallel. So, I1 equals is flowing through the 12, and the opposite resistance is 4. So it is 4 over 12 plus 4 times the main current, which is 1. So it is 0.25 ampere. And for I2, it is 12 over 12 plus 4 times 1. It is 0.75 amperes. Try to solve it in details, and these are the answers. This is a very interesting question. It comes in the Olympiad Physics, which held on United Emirates, Universal 1, year 2021. we cannot simplify this circuit, and if you use Kirchhoff rules to find or to analyze this circuit, you will make mess and it will be difficult. But if you clever enough, if you look carefully here we have a Wheatstone bridge. Is it balanced? Let us see. Divided 2 by 4 is 1/2. Now divide 1 over 2, it is also 1/2, so it is balanced. Since it is balanced, you can take 2 and 4 in series and 1 and 2 in series. So these are series, equivalent to 6. 2 plus 4, it is 6. And the other 2 here, also series, one plus 2 equals 3, and the 8 ohm is out of the circuit because there is no current flow through it since the bridge is balanced. Now the 3 ohm with the 6 ohm are parallel. The red one is 6, the green one is 3. They are in parallel, so are equivalent. If we put here A, B, C, D, E, F, are equivalent between A and C is 1 over 6 plus 1 over 3, or inverse because it is parallel, so it is 2 ohms. Then you can remove all the 5 resistance here between A and C and put only one, which is 2. And here A. This one is 6. This one is 10. And here we have 12 and 4. And here for the way to the battery we have R1 2 ohms, then the battery. Again, it is a complex circuit, but also we have another Wheatstone bridge, and lucky us because it is balanced. 1/2, the other side 2 over 4, 1/2, so balanced. What the meaning of balanced? We can remove the 10. Now 6 plus 2, it is 18 here. 2 plus 4, it is 6 here. 6 with 18 are in parallel. With 18 in parallel. This point is E. Then the equivalent resistance between A and E is 1 over 6 plus 1 over 18, all inverse. So I think it's 4. .5. Now what is the resistance up? It is 2. Now you can remove all the circuits between A and E and put only 4.5 in series with R1 all the way to the battery. So R equivalent for the whole circuit is R1 plus 4.5. It is 2 plus 4.5. It is 6.5. Now the current is BEMF over R equivalent. The electromotive force is 6.5 over 6.5. The answer is 1 ampere. Now question number 19 or goal number 19. It is for the magnetic field. A proton of mass 1.67 times 10 to the minus 27 kilogram traveling at 10 to the 7 meter per second. It is a velocity. So here we have a mass and there is a velocity. In a horizontal plane, passes through an opening. This is the opening. And it is passing through that one. Into a mass spectrometer. Yes, the mass spectrometer is not included in the material or the syllabus, but we can solve the question without knowing what is the mass spectrometer. Yeah? With a uniform 3 Tesla, since it is Tesla, it is P. Magnetic field directed upward. The direction of the magnetic field is upward. It is an additional information. Why? Because suppose that we don't know the magnetic field is upward. Can we find it, the direction of the magnetic field? Yes, for sure. How? Follow me. Here the proton is going inside the magnetic field in this direction. This is the velocity. And it is positive. Since the proton deflected to the right, so when it enters to the magnetic field, the magnetic force is to the right because it deflected to the right. Now apply the right hand rule with the thumb with the velocity. The normal to your hand, right hand, is with the magnetic force to the right. So immediately the other 4 fingers will point out of the screen, which is the direction of the magnetic field. So the magnetic field is out of the screen, like this. Okay. Now, the question needs us, the proton then moves in a circular path through 180 degrees and crashes into the wall of a spectrometer adjacent to the entrance opening. So the proton is deflected in circular path and crashes here at a distance of d away from the opening. So this d is the diameter. Forget that. d it is 2r. d it is 2r. A. Find the transverse momentum of the proton. The momentum has 2 equations, m times v or qbr. They will give you the equation in the exam like this: r equals mv over qb. This is the same as this one. Now how you can find the momentum? Either you take this one part or the other part. For this question we will take the first one. Why? Because we know the mass and the velocity. So P equals m times v, and it is 1.67 times 10 to the minus 27, and the velocity is 110 to the 7. So the answer is 1.67 times 10 to the minus 20. The unit is in Newton seconds or kilogram meter per second, because it is mass times velocity. Now, how far down from the entrance D is the proton? Now it is very easy because we have mv equal qbr. Or as suggested in the book, R equals mv over q times v. We have m times v, it is the transverse momentum, 10 to the minus 20. Q, it is 1.602 times 10 to the minus 19, and v is 3. So 1.67 times e to the minus 20 divided by 1.602 minus 19 times 3. The answer is almost 0.30347 meter. But the question doesn't need R, it needs D, which is 2R. So 2 times that. The answer is almost 0.695 meter or 6.95 centimeter or 69.5 millimeter as the question needs. Now see, find the magnitude of acceleration for this proton and the speed when it crosses 90 degrees after passing through the opening. First of all, this is the opening here. Here opening. And here is 90 degrees. So I need the velocity and the acceleration here. The velocity is tangent to the path, v. And the acceleration is toward the center. Here is the acceleration. If the object here, the acceleration in this direction. So the acceleration always toward the center of the trajectory. Now, v is constant in magnitude. Because magnetic field does not do any work. So delta K is 0. So K is constant. Then the speed is constant. So V, it will remain 1 times 10 to the 7 meter per second. Some students say that, oh, constant speed, so there is no acceleration. This is wrong. We have acceleration, centripetal acceleration. Use the circular motion. Now, the magnetic force acts as a centripetal force, which is m times centripetal acceleration. Fp, it is q dv sine theta. So we can get the acceleration as q dv sine theta over the mass. 1.602 times 10 to the minus 19 plus the 1 10 to the minus 7, sorry. V, it is 3. The mass is 1.67 times 10 to the minus 7. And the motion was normally to the magnetic field. The answer would be 2.8, almost 8 times 10 to the 15 meter per second square. This acceleration is to change the direction, not the magnitude of the velocity. So it is U changing in direction, not the magnitude. Now this is C. D, if the particle was alpha. Alpha particle has a mass 4 times than the proton and charge double of the proton. With the same speed, find its path diameter. Now, you don't need to do the calculation. Just put R equals mv over qb. So now we have the same velocity and the same p, so the proportional is to m and q. Now R alpha over R proton equals. For the masses, it is directly proportional, so m alpha over m proton times. For q, it is opposite, inversely proportional, so it is q proton over q alpha. Now put your numbers. R alpha, R for the proton, it is, we solved it for 0.03475. 0.03475. Mass for alpha, it is 4 mass of the proton. Charge of alpha is double the charge of proton. So you can cancel mass with mass, charge with charge. 4 over 2, it is 2. So R alpha equals 2 times 0.0375. What's the 4? 4 here. Which is 0.069. We solved it before. 5 meter or 6.95 centimeter or 69.5 millimeter. This is very important question. Please try to solve it, because it is paper-based questions, not multiple choice. If the particle was electron with the same speed, what are the changes in the path relative to the proton? The path will be to the other side. The proton goes in this direction. This is the trajectory for the proton. The electron will go in the opposite direction. This is the electron. This is the first time. R equals mv over qb. Now here they have the same v, same b, same q, but they are different in mass. So R for electron over R for proton. Mass of electron over mass of proton. Now the mass of electron is of order of minus 31, and this is of order minus 27. So the R for the electron, it is almost 10 to the minus 4 R for protons. Very, very, very small compared to the proton. So the electron will be like this. But to show the direction, we make it bigger, but it is very, very small. If the trajectory for electron has a radius of 1 meter, for the proton it has 10,000 meter at least, 10 kilometers. So there's a very big difference. It's not to scale, not to scale. But the most important thing is the opposite direction of the circular motion. Alhamdulillah. Last question. The figure shows a wire lying along the x-axis with a current I flowing in the negative x direction. The wire is a uniform magnetic field. The magnetic force Fb acts on the wire in the negative z direction. the magnetic field is oriented so that the force is maximum. What is the meaning of the force is maximum? If maximum when D is perpendicular to P. So since the current in the x direction and the force in the z direction, so the magnetic field for maximum force should be on the y direction. So the magnetic field to the positive y axis or negative y axis, we need to put or to take the second the right hand rule, put the thumb with the current and face your hand to face the normal to end the screen into the screen, so the magnetic field would be to the positive x-axis. So P along positive y. I'm said y or x, y-axis. You put the thumb in this direction. You face your hand because the force is into the page. So this is the thumb, this is the other fingers, and this is the back of your hand. Your hand is facing the screen into the screen. In the previous question, if the magnetic force is kada and the wire whose length is and carrying of current, find the magnetic field strength. FB equals I L B sine theta. So B, it is the unknown, it is FB over I L sine theta. Now, since the force is maximum, B is maximum, then we put here sine 90, I times L. Put your numbers. FB, it is 0.75. The current is 2.5. The length is 0.4. Sine 90 is 1. So the answer 0.75, 2.5 times 0.4, it is 0.75. Alhamdulillah, we finished with coverage. Best wishes, and I pray to Allah for you to have the maximum marks in the exam. Try hard with these questions. Thank you. See you term 3. Bye bye. Assalamu alaikum.
I hope that this series has enriched you a lot. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of the last part. Best wishes in your exam. Good luck. Salam.